Okay, everybody got, the first question on your test is what? What happens when a holding clutch is applied? This is sort of a what do you know introduction to automatic transmissions test. And, we won't be in here all that long on this. But there's another couple of little things. To begin with, I want to talk about, give you guys a little heads up on torque converters. And, you got a clutch and a flywheel and all that if you got a standard, well, there's actually a flywheel, there's a pressure plate, and there's a clutch disc if you got a manual transmission, and that's why it makes the coupling between the engine and the transmission, right? You got that. So in order to, if you ever notice how in an automatic transmission, if you pull up there on a kind of an uphill waiting for the cars to go by so you can get out, you'll have it in forward gear and the engine's running, it's idling, but you can still roll back. Got me? And you can't do that on a one with a stick, with a standard transmission. Everybody here know how to drive a standard, by the way? No. You know how to drive one? What about you? You can't drive one? Sean, can you drive one?
I'm illiterate. I can't read or drive a stick.
Huh? What?
I'm illiterate. I can't drive a stick.
Oh my goodness. All right, handicap. We got that little Escort out there, and what we usually try to do is we get the Escort where it runs and drives around pretty good, and then we will go ahead and drive it around and let you guys learn how to drive a stick and learn how to pull it up on the lift and all that kind of thing. It's really important that you know how to do that. The ones of you that don't, some people do. It's not really all that hard. It's kind of like you just got to train your muscles, and learn how to do it right. But anyway, long and short of that is, the torque converter, imagine two fans, one blowing on the other one. I got one fan that's powered up by an electric cord. I got another fan just sitting there, facing it. So what's the fan that's facing the one that's running going to do? It's going to spin, isn't it? And if I've got a load attached to that fan, to the amount of power is applied to that fan, it's going to be able to turn the load, right? So on the part of the torque converter that's bolted to the engine, the outside shell, it's got a sort of a fan inside of it. Okay, now whenever the fluid pump starts working, it's going to pressure up that torque converter, and that torque converter is going to have this fluid pressure in it, and it's going to forcibly throw that fluid against what we call the turbine. And the turbine is what's hooked to the shaft that goes in the transmission. Got it? And so when you speed your engine up, the amount of fluid that's being thrown by that, the fan blades that are on the hull, they're throwing against that turbine harder and harder and harder, and it gets to where it's turning real strong. All right, and so these two things look like the inside of a jet engine or something if you look at them. I got one cut apart that I'll show you. As a matter of fact, it's right over there. One of you muscle men, get that red one, that red thing right over there. Grab that thing. Yeah. There you go. Reach over get that torque converter. Get the torque converter and set it on the table in front of over by Gonzalez here. Sit it on the table. All right, now pick the top up off of it. All right, you see that? That's actually cut apart, but that's the part of it that's bolted to the engine. That's spinning. Now this other part that you see that's inside there is actually the part that is attached to the turbine shaft on the transmission. Now that part that's in between there, that is actually called the stator. And the stator actually redirects the fluid that has already been thrown against the turbine, so it comes back into the impeller, which is what that, the red piece is called. It comes back in there and it gives it maximum force when it's hitting these other blades. So it's really carefully built. That's your torque converter. Yeah, that stator's got a one-way clutch on it. Now, you might notice on an automatic transmission, you've got a sort of a hull coming out here like this, and then you got a shaft coming out the middle, right there. You've seen that before, right? In other words, this one's got splines on it, and that one's got splines on it. This is just real basic. There's some mild differences, but this right here is part of the pump, and it never turns. It's always real solid, and that stator, that's called the stator support. Remember that part of that transmission, you'll see it when you get a look at the transmission there. That's the stator support. This is the turbine shaft that goes in here to all your clutches and everything, right? And as it's turning all of those, the heart of that transmission is your planetary gear set, and as different parts of it are held and driven, that's what gives you your different gears. You got me? Now what I'm going to do in a little while, I'm going to show you guys a video that's going to illustrate what's going on with the planetary gears and all that kind of stuff. But a holding clutch is applied. The planetary gear set element is held and power flow is redirected. You got that question in front of you? What happens when a holding clutch is applied? The gear set element is held and power flow is redirected. And if you've got a planetary gear set, you basically have a sun gear, you got little planet gears, and then you got another ring gear that's actually the planetary gears are engaging with the sun gear and the ring gear. And so if you hold the planetary, you can hold the planetary gears still, you can drive the planetary gears, you can let the planetary gears be driven. There's all kinds of options you have here, right? So if you're holding the planet, always remember this, if you're holding the planetary gears still and you're turning one of the other gears, the gear you're not turning, in other words, the one you're not actually actively driving, is going to drive the other one in the opposite direction. And so imagine your planetary gears, and there's in your book you're going to see this too. The sun gear, and then you got your planet gears, and then you got a ring gear. All right, that, and that are all three different parts that can be driven, or you can drive them, or they can be driven, or they can be held. You see, so you got things that are being held by like a band. You know what a band in a transmission is? A band is going to go around a drum. You know this hook that's planned in there.
Yes, ma'am, it's top in.
Yeah. Immediately, who is it? Let me see. Come here.
Drop it off, she said.
Tell her, come here.
This ain't first, second, third, and fourth
Yeah.
you talking about it.
Yeah, just a minute. She needs to, Derek,
Yeah.
is that the Taurus that she's wanting the heat fixed on?
Yes.
Now, give me that work order sheet. We got to get her to write a work order on that. We got to make a work order on it. Okay. Yeah. All right. Now then, so that's the first one. Now the second one is, what do the hydraulic clutches and bands do? This is a very simple question that everybody ought to know, right? They hold and drive planetary gear sets. Basically, whenever you're holding one item and driving another one, you're going to have a different gear ratio. Got me? So the heart of it is going to be it. And the valve body is what directs all of that stuff to the various different little pistons and clutches and all that kind of stuff. We're going to tear some transmissions apart, and you're going to be able to see what all that stuff is in there. I will tell you this, that transmission repair is a very specialized field. Occasionally you'll see somebody that can just do anything, and they'll do the transmissions and the engines and the electronics and all that kind of stuff. Like I got one guy that works at a dealership in Enterprises like that. There's nothing he can't do. I mean, all the way from the power stroke diesels all the way down to the electronic to the transmissions. He just does everything. There's nothing he don't know how to do. That guy's sharp as a tack. And he graduated from here in 03. His picture's right up there, that guy. See the dark-haired guy that's working under the dash? Right, a second picture from the right by the battery cable, that's him. And he works over there. And they would probably just about sell the dealership to keep him there because, you know. Anyway, the long and the short of it is, but I was going to tell you that transmission work is something you can, basically what we do here, I don't really have time to teach you how to be an expert transmission mechanic, but you're going to learn how they work, and you're going to get an idea of how it feels to take one apart and put it back together. You're going to get to do some pressure testing, and you're basically going to be able to see how the valve body operates and all that kind of thing. But we got like 17 days for automatic transmissions, and nobody, I don't think anywhere can teach you everything you need to know about automatic transmission in 17 days. You know, because there's too many different platforms out there. You know, but we get a chance to learn some stuff about that. There's electronic part of it, there's a hydraulic part of it, you know, and then there's all the gear stuff and everything. And one of the things that it got me was people tear one apart, and they get it apart, they pulled it apart, and they looked at it apart, so they're putting it back together, and they can't get it to go back together. And, you know, they're supposed to be completing worksheets and everything, and they want me to come put it back together for them so they can get the worksheet signed off. What's the point in that? You know what I'm saying? I mean, you got to get your hands on it and get done. This one guy pulled his sister's transmission apart. He said, I can't get this part to go back down in here. And I said, what do you want me to do? He said, can you come put it in here for me? I said, no. I said, all I'm going to do is pull it out and look and see why it won't go and stick it back down in there. So he went back around there and did like I said, put it in there, and it went. And sometimes, and this is one of the things that Daniel Kelly found yesterday, I think. I had this one guy, and he's a guy I'm going to use for a substitute later this year when I'm going to Kansas City. He actually graduated from this program. He's a master mechanic. He's really good. Skinny kid that was in here a couple of days ago. And he's about 30 years old, and he's got a lot of experience in the field, so he's real solid in what he knows, you know, and he's got a lot of integrity and everything. But he was rattling around about 11 years ago. I ain't kidding you. And all right, that's what year is the Taurus?
99.
Okay. Okay, what I want you to do is find out why her heater don't work. Can you do that? Because you're in heat and air anyway. 99. Check heat. We don't know how much it's going to cost yet. Tell her to give this to Stacy if you don't give Stacy any money. But she needs to give that to Stacy right away. Don't put it off. She needs to go right up there and give it to Stacy. And then you need to find out why her heater don't work. All right, now then, but anyway, he was right, he was, about 11 years ago, he's back there in the transmission area, and he's fighting and fighting and fighting. He goes, I can't get this thing to go back down in here. I said, why don't you just go to lunch, Adam, and when you come back, it'll probably just fall in there. And he goes, huh, I've heard that stuff before, that never happens. And I says, well, you need to calm down anyway, so let's just go to lunch. So he went to lunch, and I went to lunch, you know, whatever. To come back, and he picked that piece up, and he goes, boom. Went right down. He said, what did lunch have to do with it? And I said, I don't know. I mean, I've done that when I was working in the field. I go to lunch, come back, thing fall in place. You're frustrated because you've been fighting with it for 45 minutes, you know. Okay, transmission fluid pump is usually driven by the what? Look at that. Pick that up, Gonzalez. Pick
This
that,
one?
yeah, the whole thing. Just, you know, thumb it and pick it up. Turn it up. Point it at us. Point other side, other side. Okay, that's the front that goes to the transmission. You see that? You got three, that one there is, you know, only got 3 bolts. Most of them got 4 or more. And that little puck in the middle goes in the end of the crankshaft. All right, set it down. Now pick up that red part. That red part is actually going into the transmission. You see that hub? With those little, it'll either have flats on it, it'll have a slot like that. That goes into the pump that's in the transmission. That produces the fluid, and it pumps it right back through that hole, puts that transmission full of fluid pressure. So basically the torque converter hub or pump input shaft. Sometimes there'll be a shaft that drives the pump. Like on some of them little front wheel drive transmissions they used to put in Escorts and Tempos, the pump was on the opposite end of the transmission and it had a little shaft that drove it and so on and so forth. So every transmission is a little bit different. Number 4, what happens when fluid passes through a reduced opening?
Pressure increases.
Yeah, pressure increases. So if you've got, let's say this, if you've got a, and this is really important on all kinds of stuff, if you've got an orifice right here, like let's say that you got a little place where you're measuring pressure here, and you're measuring pressure here, and you pinch that down with something like that, all right, and this gauge right here, and this gauge right here, when you're pumping fluid from that direction, or air, or anything else that is movable, then this pressure is going to rise, and that pressure is going to drop. If I take a, here's another way I can illustrate this. If I take a piece of hose and I put it in some water, let me do this right here. I didn't draw that right. I got it in some water right there, right? All right, I got it down under the water, not like that. And I take my blower, my little rubber tip blower, like here, like I got, and I blow air right here so that it's kind of going out by that hose. It's going to cause low pressure here, and it's going to pull that water out of there, and it's going to mist out of there. See, you can actually do that. You can experiment with that. Put a piece of hose in the water and blow past that piece of hose. You're basically creating low pressure, and that's kind of the same principle as the Venturi effect. Carburetors work because of that. Okay. All right. So I heard a horn. All right. Now then, let's go here. In a 1-to-1 gear ratio, the drive gear rotates what? A, slower than the gear it drives. B, the same speed, faster than the gear it drives. If 1-to-1, it's the same speed. That's there. 1 turn to 1 turn. That's a good answer. Why does transmission fluid transfer movement? What do we say about Pascal's law? You remember? What do we know about fluid? Pascal's law, what?
It cannot be compressed.
That's right. There you go. Pascal's law. You can move stuff with fluid because you can't compress fluid. Okay. Next question is number 7. I mean, are we on the same sheet? Number 7? Okay. What is the role of the hydraulic valve? Think about it. These seem like, you know, questions seem like they're Greek. Basically, it directs fluid flow or controls pressure. Basically. Now, whenever you've got a pump, you like see all these transmissions have got the older transmissions used to have a pressure control valve. And then whenever they started using electronics, they would actually have a pressure control valve that was controlled by the computer. You know, and if you actually take all of the voltage away, in other words, if you just unplug the wires going to the computer, the pressure control would be wide open. It'd be high pressure all the time. And so if you put all the power on there that you could, you know, like full 12 volts on there, the pressure goes low. And the reason they do that is because if you have some kind of a fault, they'd rather have high pressure than low pressure. Why? Because it's going to apply the clutches better and they're not going to burn up. And typically when you've got some kind of a fault in an automatic transmission where it knows there's something wrong, like if you're engine controller is looking at the transmission and it knows there's something going on that it can't do anything about, it's going to raise the pressure. And people will say, hey, my overdrive light's flashing and the transmission shifts really hard. Boom! You know, it's scary when it shifts so hard. Well, they would rather it do that than shift real soft. Why? Because whenever it shifts real soft, it'll burn it. Yeah, and it doesn't. There's not very much lining on them clutches. It'll burn them things out before you can say don't do it. You know, there's a lot of these transmissions have got a cable that's coming from the throttle valve in the transmission up to the gas pedal. Now, when you're driving a car with an automatic transmission and you want to pass the car going uphill, you're going into it really deep, right? You want it to hold the gear longer and you want it to shift harder. Am I right about that? So how does it know that you're into the gas? In the olden days, and everybody but Chrysler pretty much used a modulator valve. Chrysler always had a throttle valve. They stayed away from modulator valves forever. Chrysler has also pretty much stayed away from mass airflow sensors. They don't like those either. But the fact is, you go to this, if you got low engine vacuum, that means you got high engine load. Am I right? If your engine idle and there's no load on it, it's 18 to 22 inches of vacuum, right? And you go into it strong, you're going to have low vacuum, and so you snake a vacuum line down there and you go to the modulator valve. The Oldsmobile's got one of those on it. This 97 Oldsmobile we got out here that they were doing the struts on. And you pull that vacuum line off that modulator valve, so there's never any vacuum there, and that thing shifts late and hard. Pressure goes real high. Bam! You know. Now that sounds like you're thinking, oh, that's going to tear something up, you know. But whenever it's really, if you had vacuum trap there, it's more likely to tear something up because it's going to let them clutches slip. Okay, got it? Just remember that. And on some of these, whenever it starts going into some mode of, limp in mode where the pressure's high, if you take the battery cable off and put it back on, it'll work normal for a little while until it detects that fault again, and then it'll do that. It'll start shifting hard again. Okay, so let me back up and push. The throttle valve cable, and I started to say this a while ago, that goes up there to that throttle, it looks like a very unimportant little piece. You know, it's just a little floppy cable that hooks up to that throttle lever. And if you ever happen to leave that doggone thing off by accident, and they drive that car very far, you've burned somebody's transmission up. If that cable is not hooked up, and they're trying to drive it, and it doesn't even know that the pressure is supposed to be up, you know. Now, nowadays, they use electronic, throttle input, and the engine controller determines where to put the pressure. And it actually got a transducer in there that it tells it what the pressure is. Anytime the computer's controlling something, it needs feedback. It needs to know how it's doing. See what I'm saying? It's a closed loop. We're going to talk about these computers. This watch I got on my arm is not an atomic watch, so it don't know if it's right or wrong. It's a complicated little sucker. It's got all kinds of gears and everything in it. It doesn't know if it's right or wrong. Closed loop control is like that thermostat over there. When you turn that thermostat to a certain temperature, it's not only is it controlling the air, the air handler and the unit on top, it's actually using it to maintain a temperature. So it's a closed loop system. You got me? And that's basically like your radio in your car. If you turn the radio up and it gets too loud, your ears are telling you, I don't like that, that's too loud, and you turn it down. Or if you don't like a station, move it to somewhere else too. But the feedback is your ears. You hear me? You got that? Soak this up.
Like they use the diagnostic test on car. Mm-hmm. That you have to go through step by step.
Yeah, sort of, but the engine controller is instantly doing this kind of stuff. The oxygen sensor is a feedback on how the air-fuel is doing. You see what I'm saying? They're wanting to keep it at a certain air-fuel ratio, so the oxygen sensor is basically what the computer uses, how am I doing? And if the oxygen sensor tells it it's running rich, it's going to subtract fuel and try to get it to go lean. See, it's monitoring that feedback and it's reacting to it, and that's what that is all about. Okay, so let's drop down here, and I made the point I was trying to make a minute ago. Now let's look at output from 1 to 4 gear ratio is called what?
Overdrive.
Overdrive, because if the engine is turning slower than the drive shaft, you're getting some gas mileage, ain't you? Right? Overdrive means the engine is turning slower than the wheels, pretty much, or than the output. Ever got that? All right, you got.
This overdrive thing,
that's all
never really knew what the purpose of it was.
That's all there was for gas mileage. That's it.
So when you're on the highway, what?
When you're on the highway and it goes into overdrive, you got a torque converter lockup that applies the torque converter eventually, and it does it in stages nowadays. It'll be 10, 20, 30, 40, 50% lockup, and then it'll get to where you got a straight hookup from the engine all the way through to the the turbine shaft.
No, I mean, like
And-
on the truck, I mean, you mash the button and then the light comes on, say
Yeah,
overdrive.
yeah, and if you watch the tachometer, it'll go up a little bit.
Okay, so you can drive in overdrive?
You're supposed to turn off the overdrive when you're pulling a trailer, because it'll have a little bit more power even in the highest range.
But when you just going down the highway 70 miles an hour, you can turn the overdrive on.
You can turn it on or off. Well, when you got that button pushed, it's off. When the
You
light,
light on that says overdrive,
yeah, it's off, and you're getting worse gas mileage.
get worse gas.
Yeah, it defaults to being on because they're trying to save gas. That's what overdrive's all about. Overdrive's always been about saving gas.
I never knew that.
Yeah, yeah, just the way you see it. Well, as a matter of fact, on your GMC, it says tow haul. That's the same darn thing. So, yeah, it's overdrive is what it is. And you don't really want to pull anything in overdrive, because you're actually lugging your engine too much. And so, if you don't want it hunting up and down through the gears, on hilly roads, you can turn off the overdrive. You don't do that. But anyway, that's what overdrive is all about. Now, back in the olden days and eons ago, even manual transmissions, nowadays you just got first, second, third, fourth, fifth, and fifth is like a .79 to 1 overdrive range, and all that kind of stuff. So if you've got fewer turns on the engine than you do the drive shaft, it's overdrive one way or another, in that one right there. Now, this thing right here is a sort of a 1 to 4 gear, and that's kind of crazy. Well, think about that. If you got 1 turn input, 4 turns output, that's got to be overdrive, but they ain't never that much. It'll usually be like almost a turn to 1 turn, like 7.75 to 1 turn. And whenever Daniel finally gets that transmission put back together that he tore apart last semester, I can show you that when we get into manual transmissions, But anyway, back in the old days, they used to have a planetary gear set built into them standard transmissions, and it had a little electronic solenoid that would dog the outside of that planetary set. And you'd take off in first gear, you put it in, how many of you drove a column shift vehicle? You pull it towards you in your first, and you let it drop back in your second, then your third, and then you pull it towards you and go up your reverse, like that. Okay, now, so you pull that thing forward you, and you take off, and you let off, and it goes, donk, and you get another gear, and you didn't even move this, because that little thing was locking in that planetary gear set in there. And then you'd drive, and then you'd let off. Whenever you mash the clutch, it would release, and then you'd go up to second, and then you'd let off. And, you're never going to work on one of those anyway. That's ancient history. That's 60s, man, okay? And if you didn't want overdrive to come on, there was a little T-handle on the dash on some of them that you pull out. And that would keep the overdrive from coming on when you're pulling a trailer. Same deal. You get me? All right. But you actually had 6 forward speeds, and you know why they stopped putting overdrive on there from about 1969 or so? Because I know they had overdrive available on 69 Chevy pickups. But from about 1969 until about 1979, they didn't have overdrive because the gas companies were griping because the cars weren't burning enough gas. And so they talked to the automakers and they took overdrive off of them. And then we had a gas crisis in the mid-70s, and they started talking about putting it back on there, this blue Crown Victoria that we got sitting out here that Abby's going to inspect when we get out of here, that darn thing on the highway will get like 26, 27 miles to the gallon. I ain't kidding. I've driven them. I've checked the gas mileage, and it gets, because of overdrive. That's where the gas mileage comes from. I have beat that with a dead horse, haven't I? I've been hammered on overdrive. Make sure you understand it. Clutches and bands are applied and released by the what?
Driving mode?
The valve body. Believe it or not, the valve body does that. Hydraulic valve body does that. Yeah. Clutches and bands are released by the valve body. The valve body actually directs fluid over there. What do driving devices do? They transfer power from one component to another. That's not rocket science. Okay, which of these is a symptom of a faulty transmission fluid pump? No engagement in any gear. You've got no fluid pressure, you've got no engagement. You got me? All right. Huh? You got it? All right. Next one is, what's a symptom of worn friction discs in a holding clutch? If it slips in the controlled gear. You ever seen it? Do you know what it feels like when an automatic transmission slips?
Hesitation.
Well, basically, what happens is you're expecting it to move at a certain rate and accelerate at a certain rate when you apply the throttle. Am I right?
And it just goes up.
All right. Yeah. And if you apply the throttle, and I say, wait a minute, I'm not gaining the speed I usually gain, and you see your tachometer going, and the truck ain't going or car ain't going no faster, you're slipping. And when the clutch is slipping on a standard, it's the same daggone way. You give it gas and the engine speed picks up, but you know that it's not directly connected. There's some slippage going on there. Now, it will actually throw you codes on these new, these electronically controlled automatic transmissions. Let's say, incorrect gear ratio obtained for third gear or something like that. Because it's looking at the input, it's looking at the output, it knows what gear it's in, it knows what that differential ought to be. And if the engine is turning faster than it should, you're looking at the speedometer, you're feeling it because you know how it's supposed to feel. You're looking at the speedometer, you're looking at the tach, and if you see that tach doing crazy things. Now, when you're in torque converter lockup, which is not overdrive, that's two different things. Lockup is usually typically in your 1-to-1 ratio. See, but it goes into overdrive after you are in third and you're locked up. See, and that's why you're driving down the road 60, 70 miles an hour, your engine may be turning 1,200 RPM, which is almost no, you know. However, if you want to see if the torque converter clutch is slipping, a lot of times if you know that you're in that 1-to-1 gear, and what you're going to do is you're going to watch your tachometer and you're going to watch your speedometer and you're going to crowd the throttle just a little bit. You don't want to crowd it so much it shifts to the next gear. You're going to crowd the throttle just a little and you're going to see if the engine speed gains on it, because they both ought to go up together. If the engine speed gains, you know it's slipping. You got me? So torque converter slippage, if nowadays they actually will start out with various amounts of slippage going up, and they're supposed to have some friction modifier in it, and I've got a bottle of that somewhere in here that I get y'all to smell of, and it just really stinks something awful. A lot of this fluid's got that friction modifier in it, and it makes that slip, a controlled slip, real smooth. When the friction modifier wears out, some of you have driven a car to where when the torque converter is beginning to lock up, it feels like you're driving over those little speed warning things going up at the stop sign. You ever felt that? Like Crown Victorias will do it. And when they do that, you got to change the transmission fluid. There's really not that much to it. Okay, we're in transmission class. And some of you guys look like you're about to turn into a skeleton in here. Hey, I'm trying to keep this interesting, okay? We don't like all that much. Okay, and see, we're about 15 minutes out from being done. All right, so here we got what happens inside the torque converter at higher speeds. The turbine and impeller spin at similar speeds. Basically, when it gets to a certain speed, everything is spinning together. Now, if you do a stall speed test, and I think one of the sheets I gave out, it calls for you doing a stall speed test. You know, you get a pressure gauge and all that kind of stuff. But a stall speed test is basically one way you can tell if the torque converter is good or bad. If you got a good strong engine and everything like it's supposed to be in the powertrain department, on the engine department, and you hold the gas pedal, you put it in drive, you hold the brake pedal, you lock the park brake, you block the wheel so it can't go anywhere. You don't want to be spinning any wheels. And you go all the way to the floor with the gas pedal, and you see where the tach goes. That sounds scary, don't it? Like you're going to tear something up. But it's basically the stall speed. You got a stall speed figure in there on most of these. Now, this is what the stall speed is supposed to be. If the stall speed is supposed to be 2,800 RPM and it's stalling at 1,600, then that one-way clutch in that stator is bad. Unless the engine's underpowered or something. You got me? Okay, so that's the one way you can do that too. Now then, let's see. How would you describe the torque and speed produced by the 1-to-4 gear ratio? It's high speed, low torque. That's like overdrive. You're not going to pull very good, but you're going to go to, beat the band going down the road. Excuse me, back up to 14. The torque converter is best described as what? A fluid coupling that transmits power flow from the engine. That's a fluid coupling, right? Remember the two fans I told you about? Let's see, hydraulic piston is used to operate most hydraulic applied devices. You got a piston, you got O-rings on it, you got a bore, and it actually is going to move some stuff and all that kind of thing. So, holding devices actually prevent gear elements from turning. They're basically like a brake. A holding device is like a brake. What happens when fluid passes through an enlarged opening? We talked about the opposite earlier. What does it do, Argus? You got it?
Pressure decreases.
Yeah, it drops. That's good. Transmission fluid pump outlet port leads to the what? Ooh. I mentioned that earlier too, but I don't know if you guys caught it. Pumps it right into the torque converter. Okay, now let me ask you this. You know, you got a cooler, you got a transmission cooler, right? Looks like a radiator kind of in front of you. It's either built into the radiator or it'll be a little cooler thing. Where's that heat made? In the torque converter. The torque converter is where the heat's made because they shear in that fluid. Here's another thing. You ever been in a traffic jam somewhere like in Kansas City or somewhere where you just sat there and sat there and sat there and sat there until you was about to go crazy and you couldn't move because it was like a parking lot all the way up the interstate? And what happens is if you sit there on a hot day, like it's 110 degrees out there or something, you know, got your car and drive, and you're sitting there and sitting there and sitting there and sitting there. After a while, if you watch that line of cars, you're going to see transmission fluid start hitting the pavement. And the reason for that is when you're holding your foot on the brake and you're not going anywhere or you're going almost nowhere, it starts to heat that fluid up, and it'll get to the point where that fluid, believe it or not, actually begins to boil. And it will boil out the vent on the transmission, because the transmission's got a vent. You know, any closed gear chamber's got a vent, because